Oh, hi everyone. Today we're going to speak about Longchain4j and AI agents. Agents are all the rage today, so we're going to see how to code one agent using Longchain4j with a new module called Agentic. And then we're going to enhance that demo and create different agents that work together to do something even better. So it's a two-part demo. First, we're going to do a simple agent to understand what it is, and then we're going to do something a bit more complex to have fun with agents and Longchain4j. So let's go to the whiteboard and have a look at what we want to do today. So today is a big day. We just had a release of Longchain4j, and the Longchain4j contributors want to do a party. And for that, we're going to do agents to help us create our party. So what do we want to do? We want an agent that helps us create a recipe for a cake, an apple pie, in our example here. That's a very simple agent. It only needs one LLM, and the LLM probably knows how to create an apple pie, so it will give you back the recipe for the apple pie. That's the first thing that we're going to do today. Once this is done, we're going to do more complex agents. As you can see, the whiteboard is pretty empty. It's going to be totally filled up by the end of this demo. So let's first have a look at this first agent. So here's our first agent, the recipe agent. The recipe agent takes a name, the name of the recipe, and gives you back a recipe. It's a very simple agent. As you can see, it's a Java interface that I coded. That interface has got one method. That method returns a recipe, so what we want to have in the end. The recipe is the raw code that I coded. And that agent takes one parameter, which is the name of the recipe, as we can see here, at the recipe name, and it takes the recipe name. There are two important annotations here. The first one is @agent. So that tells the LM what this agent does. So it's an agent that provides a recipe based on the recipe name. Fairly good. You can add, of course, more details here, like your agent is always very polite. The agent always replies in French. And then there's a user message. The user message is what the user is sending to that agent. And we're saying, I'm doing a recipe called recipe name. This is where we put the parameter. Give me the list of the ingredients that I need. Again, it's only an interface, so we need an implementation for this. Let's have a look at how it's created. Here we are here. That agent is created using something called agentic services, coming from the agentic module from Longchain4j. It takes the interface as a parameter that will generate the implementation automatically. And again, the first agent is very simple. It only uses an LLM to generate the recipe. And we have the LLM here as a parameter. The chat model here, if we click, it's configured in Longchain4j. So that's a usual Longchain4j configuration. I will not go into details here because the goal is to look at agents and not at Longchain4j by itself. And that agent gives you back an output name, a recipe. So the second thing we need to understand here with agentic module in Longchain4j is that we're going to have a shared context, a shared memory between all agents so they can communicate with each other. So that first agent got a recipe name. It's sending you back a recipe, and that recipe will be in memory so we can use it later with the other agents that we will code just a little bit later. So again, very simple. We send the recipe name, we get a recipe back, and that's an agent. Let's do something a little bit more complex to understand the power of this. So we're going to do a second agent, which we will call the GitHub Authors agent. That agent is also using an LLM. They all need to use LLMs, of course, to be smart. But that one has got access to a tool, an external tool. It's an MCP server, which is called the GitHub MCP server. So this one can connect to GitHub, authenticate on your behalf on GitHub, and get data from GitHub. For example, here, the latest commits on the Longchain4j open source project. So that's the second power of agents, is that they can use tools to be smarter than just using the LLM. And they can use those tools to either request more data, that's what we're doing right now, or act on your behalf. So maybe create something for you with another tool. We will do that a little bit later. So here we've got two agents, the recipe agent that can create the recipe for an apple pie, and the GitHub Authors agent, which can give you the latest commits on a specific GitHub repository. Those two agents are going to be used together, And for that, we're going to create a third agent, which I will call the data broker agent. The data broker agent, you can see the little stick, is the orchestrator. So it's going to orchestrate those two agents and it's going to run them in parallel. So when you use agents in Longchain4j, you've got two ways to use them. You can use either what we call pure agentic AI. So the supervisor agent, the data broker agent here, will just use an LLM to decide what to call, when to call, if to call an agent. Or you can use an API with a workflow where you directly code what you want that agent to do. And here, basically, we want to request those two agents at the same moment in parallel. So we're going to code that workflow and ask Longchain4j, please run those two agents in parallel and give us back first the recipe, then the list of GitHub authors who just committed code on the Longchain4j project. Let's have a look at how this is done. So here is our second agent, so the GitHub authors agent. It's also an interface. Let's have a look. That interface, again, has got two annotations. One at agent, which tells it what it's doing. So it's an agent that retrieves the last GitHub authors from the provided GitHub repository. And then there's the user message, which is what we send to that agent. And we're asking, give me the list of authors of the last, let's change it, of the last 50 commits. Let's have more commits to have something more interesting. Of the last 50 commits in this repository that I will send you as a parameter. And so that agent is a little bit more complex than the previous one because it's still using an LLM, of course, but it's also using here a tool provider. Let's have a look at this tool provider. So it's configured right here in this MCP service. It's a Spring Bean, by the way. The Spring Bean takes a GitHub token as a parameter to authenticate on GitHub. And it's going to run Docker. So there are different ways to run MCP servers. You can access them over HTTP, or you can run them on the standard IO command, which is what I'm doing here. Again, this demo is about building agents, so I will not go into the details of MCPs servers, but as you can see, it's fairly easy to configure them here in Longchain4j. And we're going to use here the official GitHub MCP server, which is at this address. And we're going to run it inside Longchain4j. Because we can run this GitHub MCP server, while we can request GitHub to tell us who are the last committers on the Longchain4j project, and we'll have a list of authors. Let's have a look at our agent. The agent is giving us back this object, which is a list of authors. It's a record with a list of authors from GitHub. The author is got a last name, a first name, and the number of commits. And that second GitHub agent, here it is configured again, is giving us back a list of authors using this output name. So in the shared memory, we will have a recipe above and a list of authors here. Now we need to make those two agents work together. So for this, we're going to create a third agent. Here it is. So untyped agent is an interface provided by Longchain4j. This means that I'm not creating a specific interface for this because it's very easy. This orchestrator, this supervisor agent, will just run in parallel. Look at this method, parallel builder. It will run in parallel the two previous agents. So it's going to run the recipe agent and the GitHub authors agent, and we'll get back, well, both data into our shared memory. Let's go back to our presentation to have a look at what we're going to do next. So we've got three agents, the recipe, the authors, and the data broker agent, which orchestrates both of them. Now, what are we going to do with those data? We're going to create a shopping list agent. So that shopping list agent will be another agent which uses an LLM and a tool. Instead of using a GitHub an MCP server like we did just before, this time it's going to be a Java function. So we're going also to see how we can access a Java function using an agent. When we've got the shopping list, we're going to use a GIST service agent. So it's another agent that I created that also uses an LLM, but this time it uses another type of tool, a Spring Bean. And the Spring Bean is able to use the GitHub REST API and create a GIST. I don't know if you know what a GIST is. It's a little file that you can store on GitHub. So that last agent will be able to store our shopping list on GitHub. Once we've got all those agents ready, well, we're going to need a supervisor, an orchestrator agent, who will orchestrate all those agents. It will run them sequentially. So first, the data broker to get the recipe and the authors, then the shopping list to tell each author what he needs to buy in the recipe, and then the GIST service agent, which will upload the shopping list to GitHub. All of this will work together easily inside Launch-N4j. Now, why do we do this instead of doing one big prompt that tells everything to a big agent? Instead of splitting this into lots of smaller agents. There are three reasons for this. The first one is that we want specific LLMs and tools for each agent that makes them much more precise. Each agent will have the best LLM, the less costly LLM for this for the request that we give it. It will have also only one tool, the right tool to do the job. So it will be less confused. If you give it too many tools, it will be confused and maybe it will not know which tool to use. So we will have a better result. That's the first reason why we do that. The result is better because we are more precise. The cost will be lower because we only use the right LLM at the right moment, but also we limit the number of tokens we send to each LLM. Instead of sending all the available tools to all the LLMs, we only send the minimum number of tools to each LLM and the minimum prompt to each LLM. So more precise, less calls, and also this is easier to replicate. As we can see here, the orchestrator is having a workflow which is well defined, so we know this will work correctly in the way that we want it to work. So better data, less cost, and easier to replicate. Now let's have a look at how the data flows between those different agents. So the orchestrator agent is going to ask to create an apple pie. So it's going to send an apple pie to the recipe agent. The recipe agent and the GitHub authors agent are going to give us back, for the first one, the recipe, and the second, the list of authors who contributed to the Launch-N4j project. They will both come back here doing parallel calling. So again, that's quite interesting here. The workflow can be pretty complex. You can do parallel calls, sequential calls, which is what we're going to do next. You can do loops, you can do conditions. Again, it's a complete workflow API here. Now we've got the recipe and the authors. We're sending it to the shopping list agent. This one is giving us some content, so the list that we want, the shopping list. And that content is going to be sent sequentially this time to the GIST service agent, which will create the GIST on GitHub. Now let's code the shopping list agent and the GIST service agent, and let's configure everything and see how it runs. So here's the shopping list agent. So the shopping list agent is a little bit like the previous agent. So it's got an interface. Here it is. This interface, again, has got an @agent annotation that tells it what it is doing. And it's got a user message, which is a bit more complex. And it tells it that if you want to create a shopping list, you need a list of authors that will do the recipe, and the recipe with a list of items. And this will give you back a string with a shopping list in Markdown format. In order for this shopping list to be created, we're also providing a tool here. So that's a Java function. Let's have a look at how that Java function is configured. It's annotated, again, with a specific Launch-N4j annotation, @tool. And here we tell it, this tool uses the provided list of GitHub authors and recipe items to get a Markdown formatted string. This is coded manually. So here I'm doing some Java code to take all the authors, take the recipe items, and assign each item to some authors and create a Markdown list. So this is a Java function located inside Launch-N4j, and that is going to be called by our agent. So our agent uses an LLM and a Java function to create a content. That content, again, is put in our shared context, in our memory. Now, let's have a look at the GIST agent. Again, this agent uses an interface. Let's have a look. That interface has got two annotations, the agent and the user message. I think you're used to it now, so I will go fast on that one. So it uses an LLM, of course. It uses a tool. This tool this time is a Spring Bean. So if we have a look here, the Spring Bean is right here. And that Spring Bean is also annotated with @tool. so a Longchain4j annotation that tells our agent what it can do with that tool. So that tool is able to write a text to a GitHub gist. That tool is this time accessing the GitHub API. Let's have a look here. It's got a URL and it's doing a request on that URL. So that's one of the strengths of agents. Agents can use tools that can work on your behalf, and when they work on your behalf, they can access external APIs like what we're doing right now. So they can access the outside world, either to get data, that's what we did earlier, to get the list of authors from GitHub, or like here, they can write stuff, post stuff for you, and here we're going to create a gist on your behalf using that agent. So really, the agents allows the LLM to access the outside world, both reading and writing stuff, which is very powerful. So this is our Spring Bean. Let's close it. And let's go back to the code. So that last agent is sending back the URL of the gist that should be created. Now we're going to wire up everything together. So we're going to have a new supervisor agent, and that supervisor agent is going to request in a sequence the three agents that we had before, the data broker, so who requests in parallel the list of authors and the recipe. Then it will request the shopping list agent to create a shopping list, and then it will post everything as a gist. And we should get back the URL of the created gist. That agent is going to need some context, so we give it two contexts. We give it the repository, so the Longchain4j, so we give it the GitHub repositories that we want to request, in this case, Longchain4j, and the recipes that we want, so in this case, an apple pie. We can change that, of course, if we want to work with other repositories or with other recipes. And then, well, we invoke that agent, and we should get back in return the gist URL with the content that was created. Let's run this and have a look at how it executes. So here we are. This is a complete set of demos, and we're going to use the last one. Demo 16, Agentic AI with 4 agents working together. I've just clicked on it, and let's have a look at the logs to see what's happening. So I'm going to have a look here at all the post requests, because when you send a post, it's because you're communicating with the LLM. So it's a good indicator of what's going on. Let's have a look. So we had the first post here requesting, I'm doing a recipe called apple pie, give me the list of ingredients. That's our first agent asking for the apple pie. This is running in, as you can see here, in a virtual thread 91. So this is running behind the scene. Remember, we've got 2 agents running in parallel in background. So that's the first one. Let's try to find the second one. It should be this one. Like here, get the list of authors. So there's 50 commits in Longchain4j. So that's indeed our second agent requesting Longchain4j. It's running in another virtual thread. So again, those 2 virtual threads are running in parallel. We can see the 91 and 92 requesting both an LLM and fetching some data. So that's the first 2 agents working together. They should send back the recipe and authors. If we go down a little bit, this time we've got the full so authors and the recipe. We're sending everything to the shopping list agent, and the shopping list agent is giving us back the content of the shopping list that we want. Once we get that, here is the shopping list. And once we get that, we're going to send everything as a gist to GitHub. Let's go to GitHub and have a look at my list of gists. And indeed, I have a list that was created 1 minute ago, so that should be this one. Let's have a look at it. Yeah, so here's the shopping list. We can see that in order to do our apple pie, we need some pie crust, and it's assigned to this person. We need some apples, it's assigned to this person. We need some sugar assigned to this person, etc., etc. we can see Dmitro, who's the main author of Longchain4j, and we can see a lot of friends here who contributed to Longchain4j and who are all tasked to bring some ingredients to create our apple pie. You can even see myself here. I'm supposed to bring some ground cinnamon for the apple pie. So let's go back to our presentation here. As you can see, we created 4 agents and 2 orchestrator agents to orchestrate those agents. To summarize what's been going on, you can see that you can easily create an agent using an LLM. It's just an interface that uses an LLM. The power of this is that you can use tools with those agents. You can use an MCP server, which can run locally or externally. You can use a Java function, or you can use a Spring Bean. That gives a lot more power to those agents. They can now read and write data on your behalf, which is very interesting. And thanks to this new agentic module in Longchain4j, you can now orchestrate those agents so they can work together. So either you use what we call pure agentic AI, so it's an LLM that is deciding how those agents are orchestrated, or you do like I just did here. You use a workflow API, which is pretty powerful, where you can do parallel calls, which is what we did at the beginning, sequential calls, which is what I did later. You can also do loops, conditions, and so on and so forth. Now, if you want to have a look at the code that we just saw, you can go to this GitHub repository, JDubois Longchain4j demo. You've got a full list of demos. The agentic one is currently demo 16, so there's a lot of other demos if you are interested in Longchain4j. And you can play with what we just did. It's fairly easy to replicate. Thank you so much for your attention, and see you later for another presentation on Longchain4j. Thank you.